This is going to be the first workshop for this week. It's going to be on Quickstart to the graph and building custom subgraphs. We have Marcus here from the Graph who's going to be leading the workshop. I'm going to be sending him a quick invite, but up until then, just a quick note from my side. And things that you all should keep in mind, given that this is the second week of the hackathon. At the end of this week, we will be expecting you all to submit your ideas. Hello, Marcus. Welcome to the stage. We will be expecting you all to submit your ideas for the hackathon. So again, this is just an idea submission, just mostly giving us a hint of what you're planning to do and allowing us to give you all the adequate support for that. And other than that, or this workshop, just as all the other ones, will be recorded and it will be made available to you in the next 24 hours. We'll make sure to add it to the Hacker Pack along with everything else, including the presentation that Marcus has. And you will be able to follow along in your free time and rewatch everything. And do feel free to ask questions. Our Discord is quite active. If you have any technical ones or non-technical ones, feel free to post. Marcus, welcome. Are you muted, by the way?
Of course. Hi, Yasin. How's it going? Hi, everyone. Thanks for joining today.
Right. Everyone, if you do have any questions for the duration of the workshop, please make sure to post them in the chat section. Marcus will be able to follow up with you afterwards.
Yep. That's exactly the case. So what we're going to be going over today for this workshop is getting to understand the graph from a high level to a medium level, and then maybe even a little bit of deploying our own custom subgraphs and being able to index on NeoX and being able to build with NeoX in a different way, where we are not just looking at smart contracts, we're looking at organizing that data. So I hope everyone here is looking forward to that. We've got a bounty that we are offering for this, which we're quite excited for, and seeing your projects. So build cool smart contracts and use the graph, and this will show you how to do just that in this workshop. Is there anything else I should go over, Yasin, before I get going?
No, absolutely. Well, I think it's a great overview, showcasing how can people do their best in terms of, engaging with the bounty and like building for it, maybe doing some pointers on like best practices. I think all of this should be greatly appreciated by everyone. And and as I said, Sunday, idea submission, looking forward for this workshop to give people some inspiration on what to build and engage with. And hopefully it should be an interesting hackathon and great submissions afterwards.
Awesome. Yep. And real quick, Yasin, is it a hard stop at the hour block? Or
no, we're completely flexible. Okay. So if there's any,
okay,
especially like, please take some extra time to answer questions. So if you want to showcase some extra bits, I will be obviously in the audience. If something pops up, I will be quickly jumping on stage to let you know.
Awesome. And for those in the audience, if you have questions, I'm on multiple screens right here. So I will be able to see your questions and we can have a conversation live. I'm totally fine with that too. If something pops up, I'll answer the question as it fits. So let's get into it. I'll share my screen. Okay, can everyone see my screen?
Yes, just make sure to maximize so it's a full screen.
Yeah, there we go. Nope, not share. Slideshow. There we go. So, hi everyone. This is querying Web3 data with the graph. And we're going to start, like I said, at a high level, just understanding what the graph is important. And then we'll actually go and get Web3 data using the graph. And then not only that, toward the end, we'll actually be making a custom API, and that custom API is known as a subgraph, to also get some Web3 data. So depending on what your use case is for the graph, there's multiple ways you can enter. If you want to get data that's already there, go for it. If you want to create a custom way to get data, you can do that too. So if you would like, I'll drop this in the chat to this repo, but essentially this is the repo for a quick kind of how to query the graph using these different these libraries. You can use vanilla JS, Python, these frameworks, Apollo, Graph Client, which is a library that is specifically built by the graph team and one of the core devs is building the graph, and it has some really good features to query subgraphs that are already in existence. And then also going through playgrounds and DAppLooker, all of these are different ways that you can interact with subgraphs that are already live on the graph, different APIs that are live on the graph. So scan this, and don't worry if you don't scan this right now, I'll drop this in chat at the end. Okay, so Let's go into it. It's not the answer that enlightens, but the question. I love this quote so much because everything we build as builders starts with curiosity. It starts with, well, what if? What if? How could this happen? What's the use case? And then we need tools to help us really create the answer to our curiosity. And a big part of my belief and my understanding of Web3 is that it needs a decentralized way of answering questions. And that is the graph. The graph is a decentralized way of providing responses to queries, and it does it in a way that doesn't have vendor lock-in, doesn't have all these things we're trying to get away from Web 2. And I'm very, very proudly working with this organization that is building the graph. So let's talk about that. What is the graph? So let's back up a little bit and talk about the blockchain. The blockchain itself is very much write optimized in terms of just having state on chain and being able to be verifiable. It's very good at that. The problem is when we start having a lot of data essentially being thrown into this blockchain, any blockchain, NeoX or any blockchain, we have a read issue where every block is horribly disorganized because data could be coming in from anywhere and simply just being put into that block. And it's just disorganized data, and disorganized data is not performant. So how do we solve this? How do we solve this read issue in a decentralized way to get this data from the chain and then get it to our front end in a performant way, in a way that competes with Web 2, in a way that has developers happy? That's really important, to have developers be happy. So there is a Web 2.5 read solution, and that is a centralized indexer. But essentially what we have is a indexing solution that has all the same vendor lock-in problems that we're trying to get away from in Web 2. And so we don't like that at the Graph. We wanted to create an entire protocol designated to really fill the role of decentralized indexing and querying. So essentially what that is providing permissionless indexers the tools to build their own databases, to build their own indexing solutions around the world and earn tokenomic guarantees based on their actions. So anyone in this chat, anyone watching can become an indexer if they're interested in setting up a database and learning how to index data, and you can be paid in GRT for doing that. And that's a real big part of the graph, being able to be incentivized by the token, being able to be a permissionless indexing solution for people around the world. And the graph is really the platform that allows for this. And I'm really happy to be working with this. So yes, as you can see, there's a few chains listed here. NeoX, mainnet, and testnet is also supported, and that's important to mention too. So yes, that is the graph, all these indexes around the world. So yes, the graph, the decentralized indexing and querying protocol, 100 plus indexers are, I think we have 125 right now, essentially their own little companies all over the world competing for your queries. It's permissionless, redundancy. If any of the indexers go down for whatever reason, there's backups. And that's a big thing about the graph, where if there are indexers that are centralized and they go down, well, there's no backups. And that's a problem if you want to have reliability in your decentralized application. Fast, cheap, and reliable. It's 100,000 queries per month are free every single month. So you can go ahead and start building with the graph right now and be very, very free for 100,000 every month. And then after that, it's $38 per million queries. So it's quite competitive in the marketplace. And yeah, it's open data, open API, and we'll talk about that a little bit more. Yeah, and if there's any questions, feel free to drop them in chat. We'll just go from there. You might be wondering, hey, how does this apply to the hackathon? And that's really where subgraphs come in. Subgraphs are really the bread and butter of the graph. They are responsible for giving data its structure. And then once that structure is provided, you get an endpoint and you can query that data. And so let's go into what subgraphs are. Essentially, they're customizable APIs. That's all they really are. And we can design these customizable APIs. Anyone could design these. And the second thing they are valuable. Subgraphs don't exist as just a little piece of data in space. They're actually in a marketplace. And subgraphs that are well designed and have lots of queries going through them every day, they essentially are able to earn more money for the people who are investing and taking the time to look into that subgraph and say, hey, this data actually is useful to be used with the GRT work utility token. So those are the two things I want you to think of as these APIs. They're not just floating in space, they're actually part of a marketplace, and they're customizable. For the visual learners out there, this is what a subgraph essentially does. It takes a single block. Let's say we're looking at a block at the top, and the subgraph are all those little dowels. and it organizes it into a database, and that database is decentralized. So that's all the subgraph is doing. It's putting it into nice organized buckets, which then we can query, and from there we have a performant decentralized indexing solution. This is essentially the high-level understanding of the file structure of a subgraph. The three main files we have are the subgraph manifest, which is just telling the subgraph really what the shape of the subgraph should be, what smart contract or smart contracts it should be indexing, what start block it should be, also naming the database structure, naming the actual entities, how we're going to store the data, and also naming the events that we're getting from chain. It's not really going to logic yet, it's just naming the things, and that's what the manifest does. The logic is the actual transformations of the data. Are we getting the data from chain, and then are we doing mathematics to it? Are we taking the data and moving it into different locations of the database? That's where we get really creative. And then finally, we have the database itself. That's the schema.graphql. And from there, we could do one-to-many relationships. We could do many-to-many relationships. We can go ahead and really find different ways to organize the data. I personally, when I build a subgraph, like to think of the data first. I like to think what the end result I like to think of first. As I'm looking at a smart contract, and then I work out the logic in between. So we'll go through that structure in a little bit when we build a subgraph, but right now we're just doing high level, and because we're doing high level, we really just want to understand that schema.graphql on how to dive into a subgraph and to get that juicy data that we want, and that's really where the database is. That's what we're going to do. So like I said, subgraphs are valuable. This is an example. This is showing what the Graph Explorer is. And the Graph Explorer shows the marketplace of all the subgraphs that are on the Graph network. So right now there's 9,000 on the Graph network that are deployed. This is an older screenshot from, I think, last year. So it's been a few updates. I got to update the screenshot. But we'll go through this in a little bit. But that's a summary of the graph and subgraphs. There's 125 indexes worldwide. Right now, 70 chains are indexed, and 9,000 subgraphs or APIs are decentralized, indexed by many indexers around the world. It's pretty cool. So let's go ahead and start playing around a little bit. What I want to do is we're going to have a few steps to go into querying a subgraph that's live on the Graph network. It's already decentralized. We're going to go through these 4 steps. We're going to set up an API key. We're going to go assess a subgraph on the Graph Explorer. We're going to see, is this data valuable? Are people using it? Are they not? That's good to know. And then we'll design a few queries using the Subgraphs playground, the query playground. And then at the end, I'll show you a few different ways to integrate the query with a dApp. So let's go ahead and do that. This is also kind of the steps on how to use a subgraph. And this is part of getting prize money. If you are going to be querying a graph on the Graph network and using the data in your decentralized application, this is a pathway to do it. So pay attention here and learn how to query those different subgraphs that already have data waiting for you. So I'm going to go ahead and do that right now. We'll go to thegraph.com and we'll go into products. And there's 2 different options. We have Graph Explorer, where we can explore all the decentralized subgraphs on the Graph network, or Subgraph Studio, where we can go ahead and start managing some things if we're developing this. And so we're going to be developing a little bit. So we'll go here and we'll go ahead and go to API keys and then create an API key. And we'll call this the Neo Live API key. This is cool about API keys with the graph. You could enable a period spending limit, just in case you want to hit a wall with that. You can go ahead and say USD. That's going to be nice. We won't do that just for this demo, but that's going to be quite nice. Let's do, I think that's interesting. Let's do 1,000, why not? And then we create. And then from there, one thing you should always do is, when building, put some security on your API key, so it can't be potentially, well, security is always good. So just go ahead and use this when building, just to be aware of this. You could authorize a specific subgraph or to use the API key, so that's quite nice, and authorize specific domains. So a little bit of security just to be aware of. That's always good when you're in production. Anyways, we've set up the API key. We've got that. We'll just copy that right there. And then we're going to go and explore subgraph in the Graph network. And we'll do that by going to the Explorer. So how do we assess a subgraph? How do we determine what we want to build, how we want to build, what's going on? Well, there's a lot of different ways, because these are in an open marketplace. We have thousands and thousands of subgraphs. We can go through and look by index network. Now, as Neo is a brand new one, we'll see how many subgraphs are on there right now. Just a few right now, so we can deploy a few more. I think the launch, and then from there, if we want to go ahead and see what's on different chains all over, just go ahead and hop in. It doesn't, our requirements aren't that the subgraphs have to be on Neo, but I'm not sure what the hackathon requirements are for building. So if anyone wants to check that out and anyone wants to comment in the chat, I'm not sure in terms of the data source, but there's so much data available in all the different chains right through here. So you don't have to filter by chains, of course. What you can do is look at categories. You could say, all right, well, what category do you want to go into? And understand, all right, we're going to look at DAOs, we're going to look at DeFi, entertainment, gaming, governance. What API do you want to take a look at? So you can start clicking around and have some fun. That's an easy way to start assessing, what API categories do I want. Now let's look at some actual metadata beyond just the filtering. Let's look at the actual inherent qualities of the subgraph themselves, such as how many queries in one day have gone through this subgraph. 1.5 million queries has gone through this subgraph. That's awesome. 220K queries has gone through this one. So these are highly, highly trafficked subgraphs that are going through. Not many in this one, 520K in this one. We can start to see which subgraphs have more use in Web3 and which don't have as much use in Web3. And that's okay. Just hopping around here and just discovering. I like personally the Uniswap subgraph. And I also like this one right here. The UNCX lockers ones is great. There's so many different subgraphs that are available. And if all we do is just, let's say we'll do Lido here. If all we do, and us being builders, is we say, hey, we've got this subgraph. We've got a lot of indexers on there. 16 indexers are indexing this in case any of these indexers go down. There's backups. And then we can start to build a little query right here that this automatically populates. And I'll go into how that populates. But if all we do is just design a query and send it to this endpoint right here with our API key, we are already building with the graph. All right, so that's really quickly how to get going on this. I'm going to take a little step deeper into all this. I'm adding a lot of information right now in this window in just a second, but I just want to highlight how easy that is. All you got to do is design a query here, and I'll show you how to do that, and then send it to this endpoint with the API key that we just had. So now, if anyone has questions, please drop them in the chat. Right now, we're going to go into designing a query, and a good way to do that is understanding how the Subgraphs database is structured. So I'm going to drink of water. And let's go ahead and do that with a subgraph that I first got started with many, many years ago. This is, I think, now 3 years ago. The subgraphs have been around for a while. But I was first interested in subgraphs that, well, first interested in CryptoPunks. I was like, what the heck is CryptoPunks? I want to look at the data. Who's using CryptoPunks? Why? And I got curious. So let's go ahead and look at CryptoPunks here and see what's going on with them. So essentially, these are the subgraphs that are decentralized on the graph network. And these are all different versions of subgraphs that anyone, could deploy a subgraph. Anyone could deploy an API on the graph network. And we can see the queries coming in here. This one right here has 32.2 queries per day on this one right here. This one has 467. There's a few different ones that are available. These are all great. What I would say is, for me, the first one I ever got introduced to was this one. So this one might have more queries, but just because I'm familiar with this one, I'm going to dive into this one. And let's go ahead and see about this subgraph itself and learn about how the database is structured. So to assess the database and to see how it's structured and how to learn, go to the About. And then what we're going to do is actually go to the GitHub. Any good subgraph developer is able to link to their GitHub and show their repo of how they actually built their subgraph. And we're going to take a look at their subgraphs database in their GitHub. And the database is the schema.graphql. So here we can see how the database is structured. And it's okay if we don't know entirely what an interface is. It's okay if we don't know what these different things are. Right now, just understand that a good subgraph developer, as they deploy their subgraph and publish their subgraph to the graph network and make it permissionless and available to all, they all put comments in there. So any burgeoning subgraph developers out there who aren't putting comments in, please put them in, because essentially this provides plain English of what these little fields are in the database. And behind this subgraph developer has done some logic and done some transformations, which is very cool. And we could audit that if we want to. We could actually go into the code further and I could show you what they're doing. But just know that this makes us, if we're just trying to query a subgraph, we just got to go to the schema.graphql file in their GitHub, and from there we can hopefully see comments because the Subgraph developer provided comments in there. So how does this work in terms of what we're doing here? Well, let's say we want to get some answers about what's going on with CryptoPunks, and we want to see about the accounts that are interacting with the CryptoPunks smart contract. Well, this person, as a developer, has already done this. Let's look up account. There we go. I just have it there. There's the account entity. An entity is basically an object in a database, and inside those objects are fields. This is an account entity, and inside that account entity in the database, there are fields. And these are fields right here. And we can see very quickly what this account has and which account. The ID is the Ethereum address, all punks owned by the account, which is pretty cool. So that what we do is, now that we understand how this database is formed, all we got to do is go back to query, and we can query this database. So we'll go here, we'll go here. This is takes the database. This is the GraphQL Explorer, and we will go and check out accounts. So we'll go scroll up. There it is, accounts. So if you are not familiar with GraphQL, that is okay. It is the query language of choice for the graph. And so what we'll do is, no association, by the way, GraphQL and the graph are different things. So we'll look at just the first 5 in the database, and we'll look at the ID and the NFTs owned by these contracts, and we'll get the ID and the number of sales. We'll just see what's in there. All right, so we're getting data back. And so this isn't exactly a pretty query, but we're starting to design queries. We're starting to say, hey, what do we want? How do we want? You know, what's going on here? And that's kind of how we start querying the graph, because we can take this right here and send it to this endpoint. There it is with the API key, and we're already building. There's example usage already here for React, Next.js, Node, everything you need to really get going, and just dragging and dropping that query in. So let's go into a little bit more advanced querying, just for the sake of like, hey, how do we actually answer some questions? How do we actually really get some logic in there? Well, let's do it like so. So we're gonna go into the schema again, and we're gonna go check out if we're into the sales. I remember looking at the sales, because I wanted to see the sales that were performed. There we go. Is it up here? No. Is it sales? Are we down? Let's find it. Total sales. Where is it? Hasn't it changed? Sales. Sales. Is it, oh, it's just sale. That's right. Because singular. GraphQL is singular. I will find it. Sale. Sale. There it is. Sale. Sale. I'll find it. Isn't there contract? Let me just double check in my workshop here. Remember the example query right here. Yeah, first 10 sales. Let's find it. Sale. Let's type sale. I think it's in there. Let's see. Unless they actually updated their subgraph, which you can do, by the way. Sometimes the subgraph developer will update that in there, and that's okay. Let's check it out here. Yeah, we got sales. Okay, that's okay. So what we want to do is see with this sales, you can see sale. There we go. So this sale implements the event. All right, so implementation is a GraphQL type of technique here, where essentially it takes everything that is the event and makes it drop in there. So if there's a sale, we can understand in this sale who's the buyer, the amount in ETH of this sale, who's the seller, the contract metadata, more information about the contract, which has the contract type, which is pretty dang cool. The subgraph has been extended to have all these features, which is very nice. And then let's go ahead and dive into seeing these sales. We want to see the first 10 sales ever done with this CryptoPunks smart contract. So all we got to do is we'll go to sales. Hopefully that's big enough on the screen. And we want to see the first 10. And we want to understand the first 10 of all time. So the first 10 organized by timestamp. But the first 10 will get the ID of the sales, which is the actual address. I think that's the address, if I recall. We could always go back to the schema. Look at the timestamp, and let's see the amount of those sales and the actual NFT that was sold. We'll get a little bit more information about that, the token ID of the NFT. All right, so the first 10. Now, we're not really organizing this right here because this is the first 10 this index is finding in the database. We need to actually filter this a little bit more accurately. So our filter, order it by the actual timestamp. So we're getting a little more accurate. And then the order direction, do you want ascending or descending? So what we'll do, let's make this over here, order direction, timestamp, order direction. It's interesting. Nice little bug we have going on here. That's okay. Order direction, it's not dropping. Anyways, see? There we go. Interesting, found a bug. Very cool. Sometimes you find bugs. That's okay. So we have ascending right there, and we will find the, yeah, there it is. Drag it. Nope. I'm so close, guys. Run the query. It's not showing. Let's do a quick refresh. Anyways, where is this? Explorer. We're missing. That's so funny. We're missing. There it is. Ah, got it. Play. Okay, now we got it. Live demo time. Anyways, okay, so now we're actually ordering by the filtering, which is very nice. Oh, this is the original. Let's drop it in. Sales. I had it there a second ago, and I recreated it. Sales. First 10. Order by. Timestamp. Order direction. There it is. The bug is gone. And we'll have the ID, the amount, the timestamp. Let's just go with that right now. Okay, so very nice. We have the first 10 right in there. So feel free to play around, of course, with queries. Always refer to the schema if possible to understand what you're querying. And that's for subgraphs that are already deployed in the Graph Network. This is the database. All right, these comments are very nice, and they allow you to dive into the Subgraphs database and just understand that better. So cool. If there are any questions about this, I'm not seeing any questions in chat, so that means I'm doing really well and answering every question that's coming through right now. What I'll say is there's a lot of things that we can do with the queries. We can filter between timestamps, which is pretty dang cool. Subgraphs themselves can actually do a lot of compute in terms of what's happened from the very genesis of the deployment all the way up until today. And so this is an example of a good query that could be done in a subgraph. And it's amazing that we don't have to do that in the front or in the server. We don't have to do that in the smart contract. To just do this in the smart contract would be prohibitively expensive. So what we do is just do it in the subgraph. What's the total value of all sales, the total supply, the total number of sales in the CryptoPunks contracts? This subgraph developer did this in the subgraph himself. So that's pretty cool. Let's go ahead and see what that looks like. The total, let's see, total number of punks, total punks assigned to account, total number of transfers, total number of sales by account. So this is all the mathematics the subgraph can do behind the scenes. And we'll show you this in a little bit, how this is done. But just know that if you see stuff like this, that's pretty dang cool. That allows us to query and get that information in there. Total number of tokens, total number of punk sales. There we go, total sales. Where's that located at? That is on the contract entity. So let's go into the contract entity and look at the total supply, total sales, and total amount traded. Let's go check that out. So we'll go to the contract. And just so you know, just for GraphQL, if you have a singular contract, you must provide the exact ID of that. Can we get access to the links on the side? Yes, I see that right now. Let's go ahead and drop that in. Thank you. I'll drop that in the chat. Boom, boom. This is the GitHub repository. Thank you for asking that. And then I will also do the Explorer, and I'll also share the CryptoPunks subgraph itself that we're playing around with. There. And where's chat? There's chat. Bam. And this is the subgraph that's live. Cool. Okay, so let's keep on going. Any other questions? Feel free to drop it in chat. Okay, so let's keep on going a little bit with this. The TVL, what's the total value of all sales, total supply, total number of sales in the CryptoPunks contracts? Let's check that out. So if we go to contract, we don't want one contract entry in the database. We want every contract in there. Why not? And let's get the ID of the contract itself, the name of that contract, and let's see the total amount traded, the total sales, and total supply. This is all the math. And we get that all back right there. So there's two contracts. The subgraph is indexing. It's pretty cool. And we can see the total amount traded, the total sales, and the total supply. And how do we know the definition of that? How do we actually get into We look once again at the schema. I had it there a second ago, didn't I? Anyways, this is what I get for having multiple tabs open at once. We go and are able to just check the schema and then compare the schema to the database and to the query, and we'll go back and forth. It's helpful to have multiple screens open to like look at the database, create the query, look at the database, create the query, and dive in. So that's essentially how to go into subgraphs and to start creating some cool queries. There's 9,000 subgraphs on the Graph network on the Graph Explorer. So I would highly recommend developers start finding some cool subgraphs and using their endpoints with your API key, with your 100,000 free queries, and start building. That's a really, really cool thing to do. And then, make some dashboards, do some machine learning. There is a few different libraries I want to point out if anyone here is a fan of Python and doing some machine learning. What I would do is I would look at particularly Masari subgraphs. This is another feature that I'd like to go into briefly, where let's say we have multiple subgraphs and you want to query all of these different subgraphs at once. Well, it's like tough because they might have different subgraphs arranged in a slightly different way, and their databases are different ways. You have to create a custom subgraph query for every single one. Well, we have a team who's creating Masari subgraphs, which have a standardized schema, standardized database. And so if you ever see a Masari tag on there, you can just double check to see if those subgraphs, let's go ahead and open this up, at subgraphs.xyz, and you can see if their databases are similar in a similar category. So these are all bridge, and they all have schema versions. And these are all derivative per future subgraphs. These are exchanges. And if they have a nearly identical or identical schema, you could design a query to send it to multiple. So let's say, we have 1.32. I'd say most queries will work between 1.3 and 1.32. Sometimes you see a subgraph with, huge advances in their database, which is fine. Likely a 4.01 won't work with a 1.30 because they're completely different databases. But anyways, hop into this and look for subgraphs.xyz, and you could send a query to like 5 to 10 subgraphs all at once. And that's super nice because you don't have to design multiple queries. As long as they have somewhat similarly designed schemas, you're good to go. So that's really, really cool. And that's subgraphs.xyz. That's something I'd play around with. And you can get a lot of data that way for analytics, machine learning. And this is a demo query right here that we can do. This is showing the financials, daily snapshots. Basically, we're looking at the total value locked between these two timestamps between Curve Finance, we'll do this live, and Sushi Swap. And we'll just see how that's doing. These are both Masari subgraphs. You could tell they're Masari subgraphs by their tag right there. Then you go to subgraphs.xyz to see if they're in the same category. And then, oh yeah, these subgraphs have migrated. That's awesome. Okay, so see, Ethereum is deprecated. So I got to update my links in my presentation. So we'll go to Curve Finance Ethereum, and we'll drop that here. Boom, send the query. Cool. So between these two timestamps, the total value locked was here, and then Sushi Swap. Yep, this is also, and we're not on Ethereum anymore. Don't worry about this. Essentially, the Graph's token has moved to Arbitrum, which makes it much more, not performant, but I guess performance is the right answer. Much more affordable, faster. So Sushi Swap, very nice. And that's also a Masari subgraph, as we can see right there. And then, oh, why am I still on Ethereum? Interesting. Arbitrum 1, there we go. Sushi Swap. Boom. Okay, there we are. V3 Arbitrum. There it is. There's the Masari tag. And then from there, we can drop it in to that query and send and should get the data back, unless we're not getting the data back. So they might have modified the schema a little bit. So sometimes they work together, sometimes they don't. It's good to play around with to make sure that, let's go Sushi Swap, V3 Ethereum. That was the one I was looking for. Maybe I clicked on the wrong one. Yeah, interesting. So the schemas sometimes are a little bit different. So sometimes we might not have things lining up just yet. It's just go to subgraphs.xyz and see if their schemas are lining up to actually take advantage of that feature, to have the database lining up. They're always updating the databases. They're trying to get them to sync as much as possible, to line up as much as possible so we can send those queries. So anyways, a few other features of querying subgraphs. What I would say is if you're new to GraphQL, and creating some big beefy queries. Just learn about optimizing GraphQL with this cookbook. I think it's quite good. And then also what I would do for specifically for machine learning, I know that's really popular, is use Playgrounds, which is a great library that is using Python, which directly plugs into Subgraphs. You don't have to really do anything. You don't have to go through TypeScript, assembly script, or do anything else like that. You simply just use Python, and it connects to Subgraphs on the Graph network. And it's called Playgrounds by Subgrounds. Go have fun there. That's really, really well done. And for those of you who are building, who want to have some dashboards really populated without having to design the front end, you just want to get your Subgraph going, plug it in to an application, use DAppLooker. DAppLooker essentially builds dashboards that are plugged in Subgraphs, and you can build a front end off of a Subgraph really quickly. It's an automated dashboard, which is really, really cool. So that's essentially it for getting to use the graph. And that's kind of the takeaways. Ask great questions, get curious about the databases, see how they line up. Decentralized indexing is Web3 values. That's really cool, I think. And making sure that any API that we build is not going to be having vendor lock-in. And then go play in the playground. Go create some queries, compare that to the database, and from there, we're good to go. So I'm going to shift on to another way to build with the graph. So far, we've built only with querying subgraphs that are already live. That only works if you want data that from smart contracts that are already deployed. Let's say owned by somebody else. I guess you could, have one of your friends own one, and you're querying it there, but you don't necessarily own the smart contract. Well, let's say you're for this hackathon deploying a smart contract on your own, and you need to index that data, and there's no subgraph built. There's no indexing of that data built. Well, we're going to have to create a custom subgraph, and we're going to go through that right now, and we're going to get live. So once again, if there's any questions, let me know. And by the way, both ways are ways that you can be successful at using the graph. You could either build with an existing subgraph on the graph network, or create a subgraph that is a custom one. So build with one that's already here with an API endpoint that's available, and send some queries, run the database, have some fun, or creating a custom subgraph. And that's what you're going to want to do. So what I want to do, nice, we got this Solana going right there. So what we want to do is start in the graph itself. All right, so let's say we have a smart contract, and just to keep things on brand, we're going to go to CryptoPunks itself, and we say, hey, let's go ahead and dive into CryptoPunks on Ethereum. And this is the same process as regardless of the chain. For NeoX, it's the exact same thing. As long as there is a smart contract on the chain, good to go. All right. So all you got to do is find the contract itself. All right. And what you're looking for in a smart contract are the events. You really want to make sure that the events themselves are being emitted at the right time. So if we look at the events, and oh, this is interesting. That's because, here we go. We see the ABI has some events here. We have the assign event, we have the transfer event in the ABI, we have the punk transfer event, we have the punk offered event. These are the things that we're looking for in the smart contract. And any good smart contract developer creates events to be emitted at the right time, at the right place, in the right function, whenever a call is made, potentially, to emit one of these events. So let's go check one of these things out. Let's go check out I think what's interesting is the punk transfer, because we're going to be seeing, okay, there's a punk being transferred. All right, that's an event. Let's go take a look at punk transfer. Punk transfer. All right, we have that in the event, unless we're token contract. There we go, contract, transfer, where is it? They updated their smart contract, so now it's kind of hidden in here. Let's see, punk transfer. There we are, okay. So here we are. We have a punk transfer event, and it's having the message sender, the to, and the punk index. So who's it from, who's it to, and the punk index. That's what we're going to get to know with the punk transfer event. And that occurs anytime, of course, a transfer punk occurs. So the function is called, all of this logic executes, and then the subgraph, every subgraph ever built, is optimized index events. And so just remember that when you're writing your smart contract. Events are cool. So let's go ahead and index the smart contract and have some fun. We'll go to this contract address. We'll need that. And we'll go to our So let's go to our studio, and we're going to go looking for this punk transfer event. We're going to index it. We'll go to Subgraph Studio. And nice, let's create a subgraph. And we'll call this NeoX Live Demo. We'll create a subgraph. Okay, so here we are. This is the Subgraphs dashboard. You'll get to know this dashboard very well. This is where we are able to see how the subgraph is doing, how it's indexing. This is going to also provide us an API endpoint once the subgraph is deployed. So get to know this very well, and we'll talk more about that in a little bit, and how this is a private developer environment where we can test and test and test, and then eventually deploy and publish publicly, but this is all private. So how did I get to this page? I went to, let's do it together. Great question. We go to the graph, go to products, and then Subgraph Studio. And just like a YouTube studio or any other studio, this is where we can build our subgraphs. And these are all the subgraphs I've worked on in the past, but this is the one that I have right here. Create a subgraph, and then from there, this is what I'm working on right now. I'm calling it the NeoX Live Demo. You could name your subgraph whatever you want if anyone wants to code along with me. But this is what we're going to be doing together, which is great. So here, you're going to want to install the Graph CLI, and you can do it with NPM or Yarn. I've already installed it, but just for the sake of doing it with y'all, I'll do it again. And it will the thing. Who here is developing a custom subgraph for their, excuse me, custom API, custom smart contract? I know words. Who here is doing that for their project? Anyone doing a custom smart contract? Because if you are, this is what you're going to need to do. All right. All right, so I've installed the CLI, which is great. And then from there, we init our subgraph. All right, we're initializing. And it's going to have the name of our subgraph in there as a little tag on there to use. So copy paste that right in there, and away we go. So here we have a few different protocols that the graph as a whole indexes. It does Arweave, which is off-chain data. If anyone here doesn't know about Arweave, Arweave is awesome. It's off-chain data storage, really cool. And then Ethereum. So there's, I think now 70 plus EVM compatible chains that the graph indexes. And that includes NeoX, the mainnet and testnet, which is great. Near, Cosmos, and Substream. So we are going to be using EVM compatible chains here, clearly. It's here, we just fill in the name of the subgraph itself. We can change the name if we want, but just do the default. And here we can see all the chains that are indexed by the graph. And there we are, Neo and NeoX testnet. Now, just for the sake of this demo, we're doing CryptoPunks, but the pathway is the exact same for smart contracts that are on Neo. You'll just choose Neo, actually probably on testnet. So choose that when you're deploying. I'm going to be, of course, choosing Ethereum, but it's the exact same process. And Ethereum is just known as mainnet on this list. So we just choose that, and then we get the contract address. So I'm going to go get that again. There's CryptoPunks, we need the contract address itself, and then drop it in. So it's going to get the ABI from Etherscan. So this is something that Etherscan has been doing lately. We ping, the graph CLI pings Etherscan, and we try to do it over and over and over, and Etherscan just doesn't respond. So this is something we've encountered in the last, I think, like 2 to 4 weeks. So we're trying to figure out how we can get Etherscan to respond. They're not liking as much pinging their endpoints as much as we do. So we're going to have to figure that around that. But that's okay. It's asking for the ABI, which it usually in the past could pull automatically. We're just going to say, do you want to retry? No, because we're going to do that manually. And then also fetching the start block. We have to go through, and as this is more recently deployed test smart contracts you guys are building, just finding the smart contract block is going to be the best of wherever you deploy that smart contract, and define that manually. Hopefully we find a workaround for this, and we can reach out to Etherscan and be like, guys, could you let us slam your endpoint more to get this data? But they're closing it off at the time being, so we got to manually do it. That's okay. Do we want to retry for the start block? No. It's also trying to fetch the contract name. It can't get it because the Etherscans being the way they are. That's okay. So now it's asking for the ABI. So how do we get the ABI? Well, if you're developing the smart contract, you should have it in your artifacts folder. And if you're using Hardhat or something like that, it should be in your local computer. If you are indexing another smart contract that is on chain, you're going to need the smart contract to be verified. And so make sure you verify it so you can actually see the ABI in here, just a pro tip. But we have the ABI, which is good. And it's going to ask for the ABI file path, which I'll do here. I'm in this, and I'm going to open up this code. And I'm just going to save this ABI as a file itself. So you could do this a few different ways. I just like to open up the folder itself. So to do that, I'm going to make this a little bigger so people can see. I just opened up a new tab in my terminal. So this is the one I'm working on here. Created a new tab, and then I just code dot, or just open up my code editor, and it's at the same folder that I was at. And now I'm in that folder. Make this bigger. And I just want to make a new file. And I'm going to call abi.json. Any way you make a file is fine. And as long as you know where it is, that's important. I'm just going to drag and drop, and we'll copy paste that ABI right in there. I'm going to save it. Save this abi.json. And now we have the ABI. Yay. All right, so we have the file. And now I just go back to here. And I know I'm in the same folder that I was developing in. So ABI dot, it's actually dot slash. No, I believe I just type it in abi.json. That should work. Yep, that's it, because it's in the same file folder. Yay, yay, coding. And then start block. So because we can't pull it from the actual location, what we'll do is go, and I'll just pick a random start block for us to start indexing from CryptoPunks, which is fine. But what we'll do is we'll go to transactions and say, okay, we'll just choose this. You don't necessarily want to pick a start block that is 0, because that's probably not where the smart contract was deployed at. You'll be having the indexing of data start at lots of blank data, and it'll just take longer to index. So it's good to index wherever the smart contract was deployed. And so I'm just going to choose a start block here. That's, okay, I don't want to paste with tabs. That's bad. Let's just go ahead and just copy that. And let's see, can I do this? Okay, that's fine. There we go. That's what I see it's trying to do. Okay, so I'm just going to move this back from 7 to 6. All right, it's going to move back a little bit from the block height, and then from there, we'll start indexing from there. Okay, contract name. Subgraph can index multiple smart contracts on the same chain. So let's say you have 3, 4, 5 smart contracts. It's good to give every contract name accurate names. So just for the sake of good naming conventions, this smart contract is the CryptoPunks market. So I'll name it CryptoPunks market. Good practice to do. And this is where the magic really begins. Index contract events as entities. So what does that mean? Remember what I said, how subgraphs look at all the events from a subgraph, from a smart contract. Let's move this a little bit different. There we go. They look at all the events from a smart contract, and then they convert them into a database that's decentralized. That's what this line is talking about. This line is saying, hey, look at all the events that have ever occurred from this start block until today, and we're going to convert them into a database entity with the same names. So if there's a punk transfer event that we see coming from chain, it's going to become a punk transfer database entry. And then that will be organized for us to query in terms of its timeline. It's not just randomly put in there. It's put into a bucket known as an entity that we can go ahead and build with. So performance stuff. I want this spin up. I get my water because it's hot. It's hot here. Okay. Is everyone grokking this? Are we feeling happy about this? Oh, yep. All right, cool. So do we add another contract? We could, as long as it's on Ethereum. So remember, one Subgraph can do a zillion smart contracts as long as it's on the same chain. So that's cool. But we're not going to add another one. We're just going to say no. And then it's saying, hey, graph off, which will put your deploy key in here. Graph off basically connects your local setup to Subgraph Studio right here. So essentially saying, hey, computer, local setup, I want you to be able to be authenticated in here. And so you'll copy paste that into your CLI. I'm not going to do that on live stream because that has my auth code and I don't want y'all to see it. That's good operational security. And then from there, since I've already authenticated in the past, I don't need to do that. I will just enter my subgraph, which also the CLI tells you to do. So there we go. And now we're in the live demo subgraph. So let's take a look at what exactly is going on locally with the subgraph, okay? So remember in the previous presentation, there were three main files. We had the subgraph.yaml, we had the mappings, all right? And the mappings file changes its name to the contract name. If you give it a name, it'll change the file name. So that's the logic. And then finally, we have the database. So we have the high-level instructions of what the subgraph is kind of looking at, what start block it's looking at, where's the address, what chain, what are the entities in the database, what are the events. It's kind of giving a naming. It's naming the high-level stuff. And then this is the logic. This is where we do a lot of the different logic things. And then finally, we finish with the transformations and we store it in the database. All right, so it hops from here to here to here. That's the way I like to look at it. Although when I do build a subgraph, I like to start from the end result, which is starting from what do I want the organization to look like? And then I kind of think about the logic later. That's just me. So let's kind of go over this quickly. Just to kind of explain this. Remember I said the subgraph.yaml, that's the manifest. It tells us high level, what's the subgraph looking at? It's looking at, remember I put this in the CLI, CryptoPunks market, with the address we put in, the ABI that we manually put in, pulled that in there, start block. The mappings, which is the transformations. How are we going to transform the data, if we're going to transform the data? And then we look at the entities in the database. These are the entities. Remember the punk transfer event? Well, this is now an entity in the database, all right? And if we look at the event, hey, we've got the event coming from chain, and it's going to trigger the event handler, and that handler may or may not transform it, depending on what we code, and then it's going to push that data into the punk transfer entity, all right? So let's go and check that out. Let's go look at the handlers that are triggered with every event of the punk transfer event pipe. So this event, boom, comes from chain. It triggers this function to fire. It goes ahead, it creates a new entity in the database. It says, hey, we got to create a new entry in our database because there's a new event that came out. From there, we're going to look at our entity, and we have the same naming conventions. We have the event as the from. We know who it's coming from, and that goes into the database as the from field. We have the to, and that goes into the to. We have the punk index, and that goes into the punk index. We have everything from on-chain going right into our database right there. And here we can start to do some logic. We could start to do some different math. If we have more data, we could start to go ahead and combine. Let's say this entity has some data and this entity has some data. And we want to start doing some logic and bringing things in together. Super, super cool stuff, all right? Also, with every entity that's automatically spun up with the CLI, we get some information about what triggered the entity's creation. We get to know the block number, where the event was coming out. We get to know the block timestamp, when the event was actually triggered itself very specifically. And then also we even know the transaction hash that triggered the event. So some metadata that's quite helpful if we want to go into that. So we're looking at this and we're like, well, this is pretty simple. We're just taking data from chain and we're pushing it into a database and there's no real transformations. It's just, whatever, cool. I still think this is pretty cool. It's already quite powerful. Show me an example of something more powerful. Well, I got you covered there. Let's go ahead and look at the CryptoPunks subgraph. Remember, this is indexing the same smart contract we were looking at before. It's the same smart contract that has the punk transfer event. Well, let's see what an experienced subgraph developer has done to extend their subgraph and look at how they are handling their data and those triggers. Well, look how many more files they have already. They have utilities, they have the mapping is the big one, traits. They're going into a lot of different logic into this. And you might just say, well, why are they doing all this? Go through it. Go through the code and look for anything that just says event. There we go, the assigned event. And just go through and see, wow, why is this developer referring to a trait, a token ID? Why? You could think about this. You could drop this into any of your AI coding assistants and be like, hey, control A, and grab it all, control A, copy paste, and drop in, and have a conversation. Data transformed in this way to do this, and start learning about these transformations. This is the real power of subgraphs, where compute can occur, different relationships can occur, and it's done not on chain, where you can really create some really valuable analytics. But yeah, so what I would say is, here we are. This is their punk transfer that this subgraph developer did, and look how much more complex this subgraph developer did with punk transfer. I mean, it's going account holdings and finally saving to 3-4 separate actual entities in the database. So this one triggering, bam, of a punk transfer eventually modifies 4 different entities in the database. That's boom. Like, that's really, really cool stuff to get into the actual mappings. And then you might ask the same question about the database. All right, well, we already did that. Remember, we went to the schema. Let's go to the actual schema itself. And we saw all the comments that were in this database. Where is the schema? There it is, schema.graphql. And you can see how much more extension is in this schema as compared to our schema. All right, our schema is just literally passing data in. So it's helpful when learning subgraphs and like what you can do with the data, and also what you could do to win the graph prizes, to find a smart contract that already has data pumping through it, such as this smart contract, and learn what the Subgraph developer has done by looking at the database and comparing it to your database, by looking at the mappings of your subgraph and then comparing it to their mappings and being like, why did they do this? How did they do this? That's exactly how I learned. And eventually, I hope that you guys learn too, and learn some cool techniques. You can learn about techniques like the interfaces. You can learn about techniques like the derived from. You can learn about the enums. Enums are cool. There's a lot of different techniques that are possible with subgraph building, a lot of customization, a lot of compute that's possible. And I would really recommend just dive into a subgraph schema and mappings and figure it out. Yes, time to refresh your GraphQL knowledge. Yes, yes, yes. ChatGPT can help dive into just having conversations. What I'll do with a new subgraph, if I'm looking at a giant schema with like, 1,000 lines of database code, is like, I'm not going through all that. Copy, paste, drop it in. I'll take the subgraph.yaml, I'll take the mappings, and I'll start having conversations. Like, why was this designed like this? Why did this have this? Or like, I want to get this data, and start having conversations. So, sometimes the queries it designs aren't great. They don't work all the time. Is there a way to test without deploying the subgraph? Great question. Well, what I would recommend in terms of testing and developing is free. So we don't have to actually, let's go through that deploy process right now, and I'll talk to you about that. I'd recommend this as the deploy process for all builders out here. Let's go back to the studio and actually deploy this dang thing. So graph code gen, graph build, here we are. And then from there, we will deploy the subgraph, boom, and we'll get version 0.0.1, nice semver. And this is all free. So I'd recommend right now to just work through Subgraph Studio. We can see right now, since I chose a start block that was very recent, we're not getting, it's indexing nearly instantaneously, which is fine. But I could change the start block to a more past date. Let's just do that for versioning teaching right now. Let's just say, hey, we'll change the start block to 200. All right, now we have a new version. We'll save this, and we'll go back here. For the consistency's sake, I'll do it in terminal. What do we have in here? What do we call it? We called it good. We're in the subgraph itself. And we have no entities here, so we actually have to move back in the block height to deploy graph code gen and graph build. I've updated it because I changed the block height. And then now we will deploy this version 0.0.2. Nice. And so take a look. 0.0.2, there it goes. And now it shouldn't show like 99% because that was very, very quick. I want to start getting data. There we go, 207, 96. So it moved back, hopefully get some entries in this database now that we could send some queries to. But anyways, so now when building, we have a endpoint to start building with. And this is free. This is completely free to create new versions, 0.0.2, 0.01. All the versioning is done through the CLI. So we could do graph deploy once again for different versions. After you've updated the code, deploy it to here. And then from there, you could have the endpoint right there. That's no API key needed there because we're not actually on the graph network. This is all free. A great way for hackathon building right here. Nothing needs to be done to publish. Now, let's say in the future, you really like your subgraph and it's performant, fill out all the details here, and then you can press publish, and that makes it decentralized. That sends it to the graph network. And then from there, other indexers can take a look at it, add more indexers to the data. But right now, this is just being indexed by a few of the core dev teams that are working on the graph. This is centralized right now. This is just development. This is just local. This is just in this environment. There we go. Now we're getting some data popping through. We have 675 entities in here. And let's see the punk transfers. That's what I want. Punk transfers, first 10. And we did this before. Let's do the ID of the actual entity. We want the punk index to, from, And let's look at the block timestamp, and we'll order by block timestamp, order ascending. All right, so we're getting data back. There we are. Yay. This is how I would build. This is exactly how I build. I just use the API endpoint here and just keep on building. Does a subgraph node need to run its own DB? I mean, if you want to run a graph node locally and do all that yourself, you are free to. However, you don't have to for this hackathon. All of this node operation to run the database, to do all this, that is done by the core development team, so you don't have to. And that's a really nice thing about using the graph. You don't have to run your own indexing, and that running your own indexing is a whole other process. There's no prizes for running your own indexer for this hackathon. So use the indexers that are with the graph, get to know Subgraph Studio, and this is a relatively quick turnaround, just to have this versioning, check here, play with the queries, and have some fun. Okay, does that answer your question, Joshua? Yes. Yes, no, maybe so. Yes, it does. Cool, yeah. Graph node is another beast in terms of like learning it. I guess it's not crazy hard, but like just use the indexing provided by the graph. It's meant to be very friendly for developers. You get your endpoints, you get your logs right here. Lots of logs. You could use different filtering for logs, which is quite nice. This is just a testing environment. Now, publishing, that goes to the Graph Network. Remember, we did that before where we explored the Graph Explorer, which goes to all the decentralized indexers around the world. Indexers around the world are not aware of the subgraph. This is deployed on Ethereum, but this is really just for testing. You can just see the endpoint is meant for just API.studio. This is not gateway. This doesn't go to a gateway. This goes to the Graph's API, which is centralized just for development and testing. And great for hackathons, too. So that is going through our subgraph. We have the high-level subgraph.yaml. We have the transformations, which we can see some pretty dope transformations in this subgraph, in this CryptoPunks subgraph, and learn from those. And then from there, we have the actual endpoint database. Play with relationships. What's the difference between an indexer and the subgraph? The indexer, great question. An indexer runs different software, and they are responsible for running the database that the subgraph is giving instructions and rules to. But it's good to kind of think of subgraphs as customizable instructions that we're giving the indexers around the world and saying, hey, who around the world wants to index and organize this data? Because it's permissionless. Indexers around the world don't have to index every single subgraph if they don't want to. It's permissionless. And that's when it's published to the Graph Network. When it's in this development environment, of course, it's going to be indexed because this is just for testing and iterating. And yeah, hopefully that answers your question, Iomide. Hopefully. Yeah, think of subgraphs as instructions. Anyone could write the instructions. The indexer looks at the instructions and says yes or no, and that's when it's on the Graph Network. This is not on the Graph Network. This is private. This is just for our developing purposes. And I pronounced the name well, yes. Iomide. I tried. Okay. Well, that is building subgraphs. We've so far queried subgraphs that are in the Graph Explorer. We've also built a custom subgraph, and we've also looked at a subgraph that indexes the same smart contract, but is very much extended. And that's this CryptoPunks subgraph. So 3 different things we've gone over in this last hour. Basically, to win the prizes, use the graph. And that means build a subgraph custom that indexes your smart contract, or go ahead and query a subgraph that's live in the Explorer, and maybe do both. Maybe build a custom subgraph to index a smart contract or multiple smart contracts on NeoX, and then find data that is already built and bring that in. So yes, that's really cool. Can we get access to the slides and the bounty details? Yes, you bet. Let me go ahead and drop that in chat. Subgraph Dev Workshop. This is it. I've got to update a few links in there just because the graph is always updating quickly, but that's okay. This is the workshop I went over. It's been recorded here. So this will be posted online. And then Aside from the bounty details, yes, Yasin, can you please help with those bounty details? I know our teams are talking behind the scenes, so that'd be great.
Everyone, we actually have an open bounty. So the details of the bounty are being shared within the Hackerpack. Let me just quickly share the Hackerpack as well. It is something that we keep on sharing both on Discord and via email. But let me quickly show it for all of you here. It contains pretty much everything that you'll ever need to participate in a hackathon, from bounties to documentation, as well as recordings for the workshop. So you should just explore the link I've just shared. As I said, in terms of what you need to do for the bounty, it's an open-ended bounty. Marcus has given a lot of useful information and ways to engage with the bounty. A lot of it's pretty much laid out there. It was a great tutorial and a great walkthrough of how to build. So now you pretty much have all the tools now, and it's all about finding the idea that you guys want to develop, for which, as I mentioned at the very beginning, please let us know what you're planning to build. There's a dedicated idea submission form, which is due end of this week, this Sunday. Again, this is nothing too specific, just a 2-minute form of giving us an idea of like what you want to build, what you would like to create. And it will give us, it will paint a nice picture for ourselves about what type of support you might be in need of. And we'll try and support, link you with relevant people. Marcus is also sharing additional information, again, for the dashboard. So again, if you have any questions, do let us know in the Discord. We have, as I mentioned, a technical channel for technical questions. So if you're running into any difficulties, you have any issues, do make sure to be active and post these there, and we'll try and get you the adequate support.
Yeah, and yes, and please tag me too. Actually, we have this technical support chat here, but because this is a hackathon, let's filter everyone away from this and go to the actual hackathon chat that Encode is setting up. But yes, this is a lot of information that we just share with hackathons generally that we do around the world. Everything I went over is going to be also on this recording, of course, but then there's just more information here. There's cheat sheets, there's documentation, there's other workshops. Subgraphs get super extended. I mean, my gosh, they get very advanced, but you don't have to make it very advanced to win this hackathon. Just get clever, find some good stuff that is useful to your use case, do some compute, and do some relationships and have some fun.
Absolutely. And again, just a quick reminder for everyone, this workshop is recorded, and will be shared with you in the next 24 hours. We'll make sure to post it within our Discord. So look in the resources section, and we will, as I said a couple of minutes ago, we'll be added to the Hackerpack as well. So everything you ever need, always remember the Hackerpack. Links in chat, links on our Discord in the announcement. If you ever have any questions, do let me know. I'm always active, DM me, and I'm happy to give you support for the hack. Any closing words, Marcus?
Yeah, no other closing words. I think I said enough. I appreciate everyone's time, and I want to support you guys' growth as a Subgraph developer. I think if you're learning smart contracts and you want them to scale, learning how to index them and learning to get custom data, and from that, and analytics from that is really, really powerful. And it's really recommended to just learn fundamentals of Subgraph development. And this is how you do that. Just learn the fundamentals, learn how to get going with indexing the entirety history of that smart contract. And that's really where some cool stuff can happen. So thanks for your time, everyone.
Fantastic. Thank you, Marcus. Thank you all of you for being here, being so active, engaging, asking all of your questions. I hope these were pretty much well answered. Marcus did a great job with providing you all with enough examples. Again, any unanswered bits, follow up with us, follow up on our technical channels on Discord, and we'll make sure to provide all the answers you seek. Thank you all for being here. Wishing you all a great day, and see you for the next one.
All right. Take care, guys.